So next is a test for 1 function, or how we check a function is 1 or given a graph of a function, then we can check that function is 1. The test is given a function or a graph of a function, we take any horizontal line or a line which is parallel, any line which is parallel to x-axis, cut that curve at most 1 point. Meaning, if we take any line which is parallel to x-axis, then either it cuts that curve, or if it cuts, then it cuts at exactly 1 point, right? So that is called the horizontal line test for 1 function. So for example, so consider this curve, then consider any parallel line. So for example, in particular, take this parallel line, then this parallel line cut the curve exactly 1 point. If we take any parallel line here, then that parallel line cut this curve exactly 1 point. Then if we cut, then if we take a parallel line just below here, okay, just below here, then that curve not cut the curve. Then which means if we take any parallel line, then either it cuts the curve, or if it cuts, then it exactly at 1 point. So this the first function is a 1 function. So consider the second one. Consider this curve. So if we take this particular line segment which is parallel to x-axis, then it cuts here, it cuts here, it cuts here. So this line cuts the curve more than 1 point. So this function is not a 1 function. So how it is done? So you suppose consider this curve, right? Consider this curve. Then consider this parallel line. Then it cuts the curve here and here also, right? So consider the just draw a line from this intersection point to x-axis. So then we get a point x1 here, and here we draw. So here we get a x2 here. So we get a 2 different points, x1 and x2. What is image of x1? Image of x1 is this point y value, and image of x2 is this same point y value, right? So x1 and x2 are different, but its images are same. So this function is not 1. That is why the curve cut any parallel line to x-axis, cut the curve exactly at 1 point. So that such functions are 1 functions. Okay. So next is an example. Consider this curve. So x1 and x2 take 2 different points, so its images are also different, right? Image of x1 is this, image of x2 is this. So if we take any such x1 and x2 different, then its images are also different. Okay. Next we want to some examples of functions from R to R. So we can directly go to that examples. So this is a function which is 1 and 2. Okay. So the function we discussing about functions. Its domain and codomain is also R, right? Functions from R to R. So consider this graph. So this is the straight line of graph of a straight line. So if we consider any parallel line, then this parallel line cuts the our curve, or the curve itself is a line exactly at 1 point, or maximum 1 point. Either it cuts, or if it cuts, then it is once. So this function is a 1 function. So if we take any number r, any number from a real line, then it is the image of some points on the real line. So it is also onto. So next is a function which is 1 but not onto, right? 1 but onto. So function is f of x equal to e power x, right? So e is a number which is approximately 2.71. So consider, this is, sorry. So this is x-axis, this is y-axis. Okay. So this is 0. This is here it is 1. It is 2, 3, 4, 5, 6, etc. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, etc. Here below, there are numbers. This is 0, 1, 2, 3, 4, 5, 6, 7, 8. And 10, etc. on the codomain. So this is the curve. This is the plotting curve of the function e power x. Okay, e raised to x. then if we take any horizontal line, then cut that curve at most once. Then so if we take any, suppose consider a line which is passing through this 2, right, pass parallel to x-axis and passing through the 2 on y-axis, then it cuts the curve exactly at once. So we can say that it is, if we take any such a line, so if we take a line which is parallel to -2, then it not cuts the curve, right, it will not cut the curve. Then that if it so such like this, if we take any line which is parallel to x-axis, then either it cuts, or if it cuts, then at exactly at one point. So this is a one function. So similarly, if we take a consider the point -3 on y-axis, then there is no point in x-axis in which f of x is -3. So there is a -3 remaining on the domain capital R, or -3 is not the image of any point. So this function is not a O2. So this is a function which is 1 1 but O2, right, or 1 1 and O2, right. So consider the function f of x equal to x cube. So yeah, this blue curve is the graph of this function. The image of 2 is what? 2 cube by 8. What is image of 1? 1 cube by 1. What is image of 4? 4 cube, right? So 64. Okay, so like this we get a curve. So if we take any parallel line, then this parallel line cuts the curve exactly and at most once, right? So this is a 1 1 function. And if we take any point, if we take 8, then it is the image of 2. If we take any point, if we take a negative number, it is image of some points, some negative number. So this is a O2 function. So there is no point remaining on capital R. So this is a O2 function. This is a function which is both 1 1 and O2. So next is a function which is not 1 1 but O2, right? So consider consider this dotted parallel line. Dotted parallel line. Then there are 2 points, this one and this one, which cuts that curve. So it is not 1 1. But if we take any point, right, any point on y-axis, it is image of some point. So this is a O2 function, but it is not 1 1, right? If we take a if we take a line which is parallel to passing through 1 and parallel to x-axis, it cuts more than 1 point. So it is not a 1 1 function. Next is a function which is not 1 1 but O2. F of x is tan x. Yeah. So this is 0 0 1 2 3 4 etc. On the left side. We have also some curves. So yeah, this is a curve. The image of this graph is lies here. Image of graph is lies here. Image of graph is lies here. Image of graph is lies here. Okay. So this is, if we take any parallel line, which is then it cuts cuts more than 1 point. So it is not 1 1. If we take any point, it is the image of some point. So it is O2. Okay. Next a function which is not 1 1 and not O2, right? Which is not 1 1 and not O2. For example, f of x equal to x square minus 2. And if we take any parallel line, it cuts the curve more than 1 point. So it is not 1 1. So and some negative number. If we take a -6, then it is not the image of some points. So it is not a O2. So next is function which is not 1 1 and not O2. And so if we take a parallel line passing through 6, then it cuts the curve more than 1 point. So it is not 1 1. And any negative number is not the image of any point. So it is not O2. The function is actually mod x minus 2, right? Mod x minus 2, which is 1 1 from G from R to R. This it is actually not 1 1. It is some mistake I think here. So it is not a 1 1 function, right? If we take a parallel line passing through 6, then then that parallel line cuts the curve more than 1 point. So these are the many functions: f of x equal to x and f of x equal to x square, x cube, mod x, 1 by x, e power x, ln x or log x, root x, sin x curve, cos x curve, tan x curve. So these are some parent functions. So these are the building functions in in analysis, right? Yeah, so this is also some graph y equal to x square. Yeah, this is 1 1, this is not 1 1 and not 1 2, this is 1 1 and 1 2, this is 1 not 1 1 not 1 2, this is 1 1, yeah, this is 1 1 and and 1 2, and this is not on 2, but 0 is not taken real. So this is not on 2. 1 by x is not on 2 because 0 is not an image of any point, right? So this is root x, this is b raised to x, this is r square. Yeah. So our this is actually a problem. Prove that the function f from r2 at given by f of x equal to 2x is 1 1 and on 2. So how we prove it is 1 1? We just apply definition. What is the definition? F of x1 equal to f of x2 implies x1 equal to x2. So just apply that definition. So what is f of x? 2x. So what is f of x1? 2x1. What of f of x2? 2x2. What is our definition of 1 1 function? F of x1 equal to f of x2 implies x1 equal to x2. So f of x1 equal to f of x2 implies 2x1 equal to 2x2. 2 2 cancel. So x1 equal to x2. So this is 1 1. And how we prove it is on 2? On 2 means if we take any point small y in capital Y, then there exists a small x in capital X such that f of x equal to y. Okay. So if we take a number y, small y in capital R, so also given any real number small y in capital R, then there exists a small y by 2, right? If y is a real number, if 10 is a real number, then 10 by 2 is a real number. If 100 is a real number, then 100 by 2 is a real number. Then if you take a y in R, then there exists a y by 2 in R, such that what is f of y by 2? F of x is double that of x. So f of y by 2 is double that of y by 2, or 2 into y by 2. So that is y, right? 2 into y by 2 is y. So if you take any capital Y in R, there exists small x. We take what? Small x as our y by 2, right? Such that f of that small x or f of that y by 2 is small y, or f of x equal to y. So that function is O2. So this is 2x. If we take any parallel line, it is 1 1. And it is also O2.